Hello everyone, this is Ari from Pantech Learning. In previous session, we have getting into the input capture topic, right? So today we are going to do the frequency measurement. So we are going to set up the pin PA as an input. It's going to generate output pulse, and we are going to measure those pulse. Okay. So this is the thing today we are going to develop. Okay. So then we will get into the ultrasonic sensor. Okay. So next, after developing the code for those things, measuring a frequency, then we are going to get into the ultrasonic sensor. Okay. So first, we will get into the code. So we will first open the new project. Okay. Okay. So now we will select the controller. Okay. So then you have to go the core and device startup file. Include these files. Then add the .c file. Okay. So what is the first thing we have to do? We have to include the header, right? So now we have added the header. Okay. So what is the next thing we are going to do is we are going to create the four functions. Okay. So what are these functions? First is we are going to create a void of frequency generation. Okay. Void. So what is the next thing we are going to create is void of frequency measure. Okay. So next thing is we are going to create a delay. Okay. We are going to create a software delay. Okay. So delay of this is a millisecond delay. Okay. So these three things we are going to create a function for. Okay. So first we are going to create a function for this frequency generation. Okay. So what is the first thing we have to do? First we have to choose which timer we are going to use and which channel we are going to use. Okay. So go to the reference menu, go to the data sheet and go to the pin descriptions. So you can see in a PAF1 we have a timer to channel 2. We are going to use this pin as a PA1 pin as a frequency generation, and we are going to measure it by receiving the frequency. We are going to capture this frequency in this timer 9 channel 1 in PA2. So we are going to use two pins, which is PA1 and PA2. PA1 is going to generate the frequency, and PA2 is going to read the frequency which is coming from the PA1, which is coming from the channel 2 of timer 2. So which is going to capture the input, it is going to capture this timer 9 channel. Okay. So for this, we have to go to the then go to the AHB1 ENR. In this we have a GPO in this GPO in 0th bit, right? So we will enable this first RCC of AH is equal to 1 left shift of 0. So this will enable my GPIO. Okay. So what is the next thing I have to do? Next thing is I have to set the model register. Okay. So go to that. So in this, go to the GPU registers. In this model, you have to configure this PA of 1 because we are using the pin as PA1, which is which has a timer 2 channel 2, right? So you have to configure this pin as an alternate function. So for alternate function, I have to set logic on this third bit. So 1 0. So we will simply left shift 2 to this bit, which is second bit. Okay. So left shift of 2. So this will set my pin as an alternate function. Then we have to select the alternate function, right? So we are using this timer 2, channel 2, right? So go to the function description. Function description. So we are using pin is from 0 ranges from 0 to 7. So we have to configure it in the low register, right? So we have the timer 2 in the alternate function 1. Okay. And okay. So we will go to the low register. So it is alternate function 1, right? So I have to simply left shift 1 to this fourth bit. So this will set my alternate function. So GPIO AF of 0 on left shift off. In which bit I have to send to the fourth bit. So this will set my alternate function AF of 1 in the timer 2. Then we have to enable the clock for the timer. So which timer we have to enable it? It is for timer 2, right? So timer 2 is in the APP1 bus. So you have to send the logic 1 to the 0th position because you can see we have a timer 2 in this 0th bit. So we will send this RCC of APB on ENR is equal to 1 left shift of 0. So this will enable our timer 2. So next, so what is the next is we have to set this timer's prescaler, right? So what is we are going to use a millisecond, we are going to use a millisecond or microsecond. So we are going to, so we have to decide our 1 hertz of frequency is, the time duration of 1 hertz frequency is 1 microsecond or 1 millisecond. Now I am going to configure it as a 1 microsecond. So 1 hertz of frequency will be, takes a time of 1 microsecond. Okay. So we have already, I have already shown you how to derive this prescale value in our timer session. So if you have any doubts, means you can verify to those timer videos to how to derive this prescale value. So it will be available for the internship students. So it will be, the recorded videos will be available and also will be available in the YouTube for some days. Okay. So the prescale value is going to be 16 minus 1. So it is 50. Okay. So now we have set the prescale value. So what is the next thing we have to set is, we have to set the auto reload value. So what is the auto reload value means? The timer will start from 0. It will reaches the auto reload value and again it gets to resets to the 0 and again starts from 0. So I need a frequency duration of 10 microsecond. So my line should be at the starting state, it should be idle and it should be go to the logic 1, and the time between the time of the I level is should be the duration of this logic 1. It will from ID line it will go to the logic 1 and again it comes to logic 0. So the time gap between this logic rising edge and the falling edge, this I am going to calculate it. So this is the duration I need to know. So what is the thing I am going to do is I am going to generate this frequency. So I am going to set the log. I'm going to send the I line from 0 to logic 1 and I'm going to hold it in the I level for 10 microseconds of duration. Then I'm going to make it logic 0. So this is what going to happen. Okay. So I need is, what is the thing I needed? I needed is 10 microseconds of duration in the I level in logic 1. Okay. So timer 2 of auto reload. So in this auto reload, I'm going to give it to 10 minus 1. So it is going to it is going to count from 0 to 10, 0 to 9. So it means it is going to give a each value one represents a each one digit represents a 1 hertz, right? So if it counts from 0 to 9 means it is going to be 10 hertz. So 10 hertz means it is going to be 10 microseconds. Okay. Okay. So what is the next thing we have to do is we have to go to the we have to select the channel as a output, right? So for that go to the timer 2 registers. So we have this timer 2 registers. Wait, we will see it. Okay. So we have these timer 2 registers. Go to the CCMR of 1, which is a compare capture mode register. Okay. So in this in a CCMR of 1, we have a channel 1 and 2. So what is the channel we are using is channel 2, right? Because the PA of 1 pin has a timer to channel 2. So now I have to configure this 8th bit from 8th bit because from 8th bit from 0 to 7 it is channel 1 configuration, 8 to 15 it is channel 2 configuration. Okay. So we will refer to these things. So for selecting as an output, we have to send logic 0. We have to set logic 0 in these both the bits. Okay, 0 and 1. So it is in this case 0 and 1, 0 and 1 bit represents a channel 1. When you for setting the channel 2, we have to send the value to the 8 and 9 to select as an output. Then we will. So then this is the first step we have to do. Okay. So first thing we will do this. So go to the timer of 2 in this CCMR of 1, right? So in this I'm not going to do is CCMR, I'm going to send the logic zeros in these both the bits, which is 8 and 9, because we have this. So you can see this channel 2 as an 8 and 9 bit. We have to set logic 0 in these bit to set as an output. Okay. So we will send this. So I will shift this 3 to the 8th bit. So this will set my logic as a 0. So it will set the logic only in those 2 bits and it will going to invert it. So you can see this, right? So we have a warning. So it is what is this warning is saying? It is converting the into unsigned offering. So now we have to typecast it. Okay. So what we are going to do is u int of 32 of t. So this is the typecasting. So this will now the warning is removed. So now we have used this unsigned of 0 to 32. Okay. So what is the next thing we have to do? Now we have set the out. Next we have to say the output compare. Okay. So for that again you have to go to the CCMR, go to the CCMR registers. In this we have a dedicated bit from 12 to 15. So you can see this. These are things for output. Okay. These are things for input. Okay. So you can see we have a dedicated bit of 12 to 14 for this output compare mode. So you can refer to these 4 bits. So these are the things which you reference. Okay. So you can see the 4 to 6 bits we have to say this, which is the mode we are going to use this. So what is the mode we are going to use this? Toggle. So we are going to use this toggle mode when the CMT count register is equal to CCR of 1. It is going to toggle when this count is equal to CCR of 1. So you are going to use this. So what is the sum of these values? 1 plus 2 is 3. So we will left shift this 3 to the, we should not left shift the 3 to this 4th bit because it is a channel 1 representation. We have to send this to the, which bit? We have to send it to the 12th bit. So it is for channel 2. Okay. So we will again, we will take this copy and make it paste. So CCMR of 3 left shift of 3 left shift of 12. Okay. So this is going to be a, now we have selected the asana, we have selected the output mode. Now this is what going to do is it is going to select as an output. Then we have to set the output mode. Okay. So now we have set the output mode. Okay. So what is the next thing we have to do? So next thing is we have to wait. So we have to make this wait, so you can go to the CCR of which is the channel we are using? We are using is channel 2, right? So we have to make it as a 0. So we have to start, we have to make it initial stage as a 0. So go to the timer of 2 CC or of 2 channel 1 is equal to 0. Okay, so this is making the, now we have set the initialized value for CCR. So what is this next thing we have to do is we have to enable the output and we have to set the polarity. So what is the polarity is going to say is what is the starting stage of the line. It should be low or high. Okay, so we will see here. So go to the CCR and time and 2 registers. Okay, so go to the CCR. Wait, CCR. Okay, this is timer 2, right? Okay. So in the CCR, we have to configure these channels. So these first 3 bit is dedicated for channel 1. These 4 to 7 dedicated for channel 2. Like this, we have till channel 4 in this CCR. Okay. So you will refer to this channel once. So we are going to use this as an this timer as an output, right? So first we have to send. Right. So what we have to do is we have to first enable this capture. So this is for channel 1. So we are going to send the logic 1 to this channel 2 enable bit. Okay. So when this we send this logic 1 to this bit means it is going to select this. The output capture signal is output on the corresponding pin output pin. So it is going to send this frequency in this output pin. So for this we are setting this bit. Then what is the next thing we have to do is we have to set this polarity. So active IR, active low. So what is the stage? It have to start it. So I am going to configure it as an active load. So these 0 and 1 for is first channel. So we have to see this 4 and 5 because we have, you can see here. So second channel 2 represents the second channel. So this is enable bit, this is polarity bit. So we are going to send the logic onto this 4 and 5. Okay. So we will send those things first. So timer of 2 in this, which is we have to go to CCR. This I am going to send one left shift of 4. So this will enable my output. Then I'm going to one left shift of 5. So this will set my initial ideal line as an logic 0. It starts from logic 0. Okay. Active low, which means active low. Then we are going to make the count register as an 0. So we will start it from 0. We will initialize it. Okay. So what is the final thing we have to do is we have to enable the counter. So we know that counter will be in the control register of 1 in the 0th bit. Okay. So I still say we saw that. So in control register of 1 left shift of 0. So now we have finished the function for frequency generation. Okay. So next we have to measure the frequency generation, right? So for that we will create a function. So for this we are going to use the timer 2, right? Timer 9, right? So we have the PA of 2 in the PA of 2 pin. We have a timer 9 of channel 1. So we have to configure this. Before that we have to enable this GPIO, which is the port of GPIO, because we are using the timer 9 channel 2 is in the channel 1 is in the PA of 2 pin. So we have to enable this GPIO proper. Then what we have to do, we have to set this motor register. Wait, I will make these things all. Then we have to set this alternate function. Okay, so we will set these things first. So what is the pin? So we will go to the GPIO. Okay. So in this, we have to send logic 2 to the 4th bit to use this pin PA as an PA2 as an alternate function. Okay, so we will send this first 2 left shift to 4. So this will set my alternate function. What is the next thing I have to do? I have to say which alternate function I am going to use it. Okay, so go to this functional description. So we have to see this low register because our pin is, it is inside this 0 to 7. So where is the timer 9? So we have the ordinate function 3 as a timer 8 to 11. So we will set this ordinate function of 3. So what is the value of ordinate function of 3? So go to the low register. The ordinate function of 3's value is 1 plus 2, 3. So we have to send this logic 3 to this 8th bit. Okay. So we will send this 3 left shift of 8. So now we have set the alternate function. What is the next thing we have to do? We have to enable this timer, right? Timer 9. So timer 9 will be in the which bus? So for this you have to refer to the block diagram. So guys, you go and refer to the block diagram. I will directly go to the bus. Okay, because I know where it is. ABB of 2 now. In this you can see we have a timer 9 in this 16th bit. So we will send logic 1 to this. So RCC of ABB to now. So in this bus I'm going to send logic 1 to the 16th bit. So this will enable my clock for the timer 9. So what is the next thing I have to do? I have to set the prescaler. So my frequency generation is in the, what is the frequency it is using? It is using the microseconds, right? So 1 hertz takes a time period of 1 microsecond. So I am going to read the frequency in microsecond only. So I will come into timer of 9 in this PSC prescaler of 15. So we are going to use the same frequency as this generation. So what is the next thing is I go to the CCMR in this timer 9. So we will have a separate registers for timer 9 to, so this is timer 2 to 5. So we have a timer 9 to 4. So in this go to the CCMR of 1. So in this you can see the timer 9 and 12 CCMR of 1. So what is the channel we are using is channel 1 right here. Okay. So what is the first thing we have to do is we have to use configure this channel as an input. So for this purpose we have to send the 0 and 1 as an, we have to send this logic 1. So we have to set this 1 and 0 bit as a 0 1. So to configure this, okay. So I will simply left shift the logic 1 to this 0th bit. Okay, so this will set my input capture mode. So what is so timer 9 off. So in this time 9 CCMR of 1. Okay. So in CCMR of 1 we have to left shift this logic 1 to the 0th bit. So it will, what it is going to set? It is going to set the input capture mode. So we will set this input capture mode. Okay. So what is the next thing we have to do is we have to set the time. Okay, so for that we will go to the registers. So you can see we have an input filter. So in yesterday's session I have shown you in the block diagram that it is the frequency will get into the, first it will get into a filter, then it will get into a, gets into a edge detectors, right? So we have to set this filter value because it is going to filter the noise. Okay, so we are going to set this filter value. So what is the value I am using is N6. So we have to send this what is the value I have to set? I have to set 5th bit as a logic 1. So what is the value of my 5th bit? It is 4, right? So I will left shift this 4 to this 4th bit. Okay, so this will set my, I will we can left shift this 4 to the 4th bit, or we can left shift that one logic 1 to the 6th bit directly. So this will set my value as a noise reduction or filter as an N6. Okay, so we will do this. So timer of in timer of 9. What is the register we have to configure it? We have to configure CCMR of 1, right? So in CCMR of 1 we have to on left shift of 6. So this will set my, what is it is going to do? It is going to set the my filter value. Okay, so next we will get into the CCER in timer 9. So we have this CCER. So what is the thing we have to do here is we have to select this 0th bit as a capture enable. We have to enable this capture. Then we have to say in which edges it have to capture it. So we have to capture in the rising edge or a falling edge. Always you are going to check the both the rising edge as well as falling edge. So in our case, what we are going to do? We are going to calculate the time period between the rising edge and falling edge, right? So what is the value we have to set here is we will send the logic 1 to this enable bit. It will enable the capture enable. Then we will send this. You can see. So what is this sum of this value? 1 plus 2 it will is 3. So we have to send the left shift the 3 to this first bit. So this will set my mode in non-inverted both edges. So it is going to capture the both edges. Okay. So next, then we have to send this logic one to this polarity, output polarity bit. So if I send this logic one to this bit, means it is going to work as per this both edges. Okay. So we will do this. Of 9. In this we have to set bit is CCR. In this we have to send this. What is the logic? We have to send first. We have to enable the capture, right? So on left shift of 0. So then what is the next thing we have to do is we have to capture the both edges, right? So one, then we have to left shift this 1 to the 3. So now we have configured this thing. So what is the next thing we have to do is we have to initialize the CCR of 1 as a 0 and CNT as a 0. So timer of 9 CCR of which channel we are using is channel 1, right? So 0, then timer of 9, right? So in this count register is, so it is we have to do the count register. Count register is equal to 0. Then finally we have to enable the counter. So it will be in the control register, right? So we know that. So one left shift of 0. So this will enable my counter. So now we have created this frequency generation function, and we are going to measure those frequency which is generated by this function using this measurement function. Okay. So what is the next final step we have to do is we have to create a delay for software delay for milliseconds. Okay. So okay. So next is we are going to create a void of delay in software, right? So what is the thing which this is already we have created in the previous session. So I will do it fastly because yeah, no time. For of delay. So we have to initialize the delay of 0 and delay of minus. Okay. So what is the next thing we have to do is for of I is equal to 0. So it is going to start from I and I is the shift of. So guys, you can note this. It is going to create a perfect millisecond delay in software by using a software. So we don't need to configure the timer. Okay. So now we have created this delay function, right? Right. So what is the next thing we have to do? Sorry. Okay. So next is finally we have to create a main function, right? So int main of void. So what are the things I'm going to do inside this main? So I'm going to first call this frequency generation. So I'm going to generate the frequency first. Then I'm going to read this frequency, right? So frequency of measure. So what is the next thing I'm going to do is I'm going to give the delay of 60 milliseconds. So this why we are giving this 60 milliseconds of delay, I will explain later when it comes with ultrasonic sensor. Okay. Okay. So next is we are going to create a while of 1 inside this while. We are going to check whether this interrupt is occurred, whether this edge is detected or not. So for that, what you have to do, you have to get into the timer 9 of status register. So in this time 9, we will have a status register. So in this, you can see this first bit. So this first bit is going to be see here. So this bit is set by the hardware when the capture event is occurred. So it will when this edge is detected, it is going to set the logic one in this flag. So we will wait till this bit is get set. Okay. So we will create again. We are going to create a while inside it. So while of time and IN in this status register, right? In status register, I'm going to undo with one left shift of 1. So I'm going to check it with this bit, right? So I'm going to wait till this bit is get centered. Okay. So what is the next thing you have to do is when this bit is get settled means what it says. So the edges, rising edges, first rising edge is detected, then you can capture it. So we can capture it, right? Now for capturing, we are going to create the where we have to capture. We have to store the captured value in the some variable, right? So for that, we are going to create some values. Okay. So static of. So what is the meaning static is going to do? It is going to declare my variable all over the program. So this variable can be accessed throughout the program from anywhere and anytime. Okay. So that is why I'm using static. So I'm going to. So first we have to know what is the frequency, right? So what is the frequency? So next is I'm going to declare a static of signed off. In this I'm going to do a start. Okay, so I will initialize it as a 0. Static of unsigned off int of int. Okay, equal to 0. So what is the next thing we have to know is we have to know the duration, right? So for that because we are calculating the duration between the rising edge and the falling edge. So we have to know the duration. So by knowing the duration only, we know. So for how many microseconds it is in the logic I. Okay. So for that unsigned of int of duration. Duration is equal to 0. Okay. So it is equal to duration is equal to 0. So we have declared these four values. So when this edge is detected, I'm going to store the value in the I'm going to store this value in the timer of 9 in this CC, which is the channel we are using. We are using a channel 1, right? So channel 1. So next again, I am going to check this flag. So by reading this CCR of 1, it is going to clear this flag, which is a edge detected flag. Then I'm going to wait till wait for the down edge, falling edge. Then when this falling edge is detected, then I'm going to store this capture the CCR value time microsecond time in this and okay timer of 9. So in this 9, we have to send this CCR. We are going to capture these. Okay. Now we have captured the time at rising edge and the falling edge. So we have to find the duration, right? So we have already seen this how to calculate the duration formula in this previous class. So I will direct this. So duration is equal to int minus start. So it is going to derive me a what is the time period between the rising edge and the falling edge. Okay. So then we have to know the frequency. So frequency is equal to, so now I am going to divide it with this. What is the frequency we are using? We are using is 16 hertz, right? So 16 hertz. So we are better the value is 1 megahertz. So 1 megahertz which gives the 1 hertz is equal to 1 microsecond. So then we have to give the same frequency here. So 16 point of 0 f. F will says that it is a float. Okay, because we will get the frequency in the float value. So when we are doing it, we have to divide the duration. Okay. So what is this warning is saying is the implicit conversion of unsigned into float. So this is converting the float value to this. So for this to avoid this value, we have to do this typecasting. So it will say that it is a float. Okay, it will convert this into a float. So now we have avoid the warning. So we have done these things. So now we will check these all the values. We will read these all the values. Okay. So then we will add some delay here, some millisecond delay here. Okay. So it is not basically needed. We can add it. So first we will compile this. We have no errors. So for one is the errors. Okay. So before uploading the code, what we have to do? We have to select the STLink debugger because I'm using is discovery board. So it will compile in the works in the STLink debugger only. Okay. Always you can use the STLink. So trace is 8 megahertz. Okay. So now we have compiled it. Now we will connect this. Okay. So we will So what we are going to do is we will upload this code and we will check the output. Okay, I will get into the debug. So I will add this value to the watch. Okay, I will add this value to watch one. Okay. Now we have added these values. Okay. So frequency one we will get in the flow plus. Okay. So what is the thing is I'm going to do is PA1 is going to generate the frequency and pin PA of 2 is going to read the frequency, right? So I'm going to use the jumper cable and I will short those things. Okay. So now I have shorted it and we have upload the code, right? Wait. Wait a second, guys. It is my ID is not responding. Wait a second. So now we will upload this code. Okay. So now we will upload this code and we will see the debug. So now I will start the process. So you can see this. Our frequency is getting at 1.6 because we are sending a 10 microsecond of H. So you can see the duration of from my rising edge to falling edge is my duration is 10 microseconds. So what is it? It is denotes it is sending the 10 hertz of frequency. So 1 hertz of time period is equal to 1 microsecond. So it is sending the 10 microseconds. So for to get this, you can see this frequency is 1.6. How to derive this value? So you can derive this by, so what is our frequency? It is 16, right? So 16 divided by what is the value we needed? It is in the question mark. So it's equal to 10 megahertz. So if you divide the 16 divided by 10 hertz means the value you are going to get is frequencies. The frequency formula is frequency is equal to megahertz frequency, 16 megahertz of frequency. So we have already divided it. So what is the frequency we are using? 1 megahertz. So 16 divided by what is the hertz we need is 10 hertz. So if you give that means we will get the frequency for value as 1.6. So you can see this. This is how we will send the frequency and measure it. So even we can wait, we will change these values. Okay. So now I will send this 1 hertz. Okay. We will send this 1 hertz by changing this auto reload value. So I will yeah. Okay. So now you can see my frequency is 1 and my duration is 16. Okay. So this is how we will measure the frequency. Okay. So okay. So today we have seen this things how to measure the frequency and how to generate the frequency. So in this tomorrow's class, we are going to see the get into the topic of ultrasonic sensor. So we will it is a it is a sensor. We are going to interface with the CM32 controller, and we will measure the frequency and we will measure the distance. Okay. So before ending the class, we have something left to do. So wait a second, guys. 1 second. So today we have seen this concept and tomorrow we are going to interface this ultrasonic sensor. We are going to use this same concept of frequency generation and measurement. Okay. So today's class is over. Before that we have to. So before getting into the next topic, now you can convert this masterclass into an internship, guys. So it is in a 1 month internship on embedded systems. So we are already learning the STM32, which is based on ARM Cortex M4 in a register level, right? So we are learning like in a register level. So it will be a very much useful for you. So you can you have to when you have to improve yourself, you have to practice on these things. So while practicing, you need some internship like a reference like what are the ins, what are the bugs, all things you have to need some reference, right? So for that purpose, this internship is provided. And in what is the benefit of this internship is lots of topics you can refer to this internship, and lots of things going to be added in this internship, like CAN, LINs, lots of communications and tax core concepts all coming on the pipeline of courses. So don't miss this opportunity. Our fees is 1,200. So our discount price is 599. Okay. So you can use this ESMC1 coupon code, and by using this, you have to pay only 691 only. So by paying this fees, you can register for the internship and you can get more benefits. Okay. So now we will get into what are the benefits you will get. So as I said, so we are practicing lots of codes, right? So we are practicing lots of codes in the live session, and you are developing lots of core concepts. So you have to practice yourself for making to upskill yourself, right? So when you are practicing, you will come with some errors, or you will have some doubts related to those things, or you will after executing the code, you will not get output like these things. So for that purpose, you can refer to these 30 days videos. So what is the best benefit is the 30 days of masterclass live sessions will be available as a recordings in this internship. So and lots of topics also going to be added to those videos. So it will be accessible for those recordings will be accessible for 90 days. So you can use those videos as an reference for hands-on practice and developing a while developing a code. And even the concept is you are not clear with the concept means you can again rewatch it. So the concept will be get clear. Okay. So and what is the next benefit? So next benefit is we are going to do lots of hands-on practice on embedded projects, and you are going to implement what is the project I have teached you, and you are going to implement those in real time by yourself. So while developing the project, you will get lots of errors and lots of bugs. So you can in this internship we will provide a lots of practice on embedded projects, and you can ask the questions to clear the doubts to myself as a me. Okay. And what is the next benefit? So next benefit is you will get a 30 days of download presentations. So I'm giving a presentation right for 30 days. So you will get this. Plus additionally, what you will get is what are the things we are using. We are using data manual, reference manual, programming manual, user manual, lots of things. So those are all the things what are we are using to develop the code, and all the things we use to learn the code concepts and communication protocols. All those files also will be included in these 30 days of downloadable presentations. So you will get the presentations as well as what are the things we are using for developing code and the projects. And also in addition, you are going to get a codes that I am developing. So I have developing a code in live sessions, right? So those codes are going to be .c files. It will be shared you as in a format of .c file. So you can refer to those codes also. So it will be exclusively available for these internship students. So you can you can get those codes also. So you can use those codes for reference also. Okay. And what is the next benefit? Since we will have a one-to-one live sessions. So what is this? Is you can interact with me for 1 hour every Saturday class. So you can ask the doubts. You can clear the doubts related to the topic which I have taken from the day 0 to till the date, or even you can ask the doubts related to the embedded systems out of the topics which I have. Now I am taking STM30, right? If you have a doubts related to the other microcontrollers, or you are doing lots of or you are involved in other embedded projects, you have a doubt related to those projects, or you have doubt related to this other microcontroller means you can also use those mastermind class to sessions to ask the questions related to the out of the session also. So you can ask the doubts related to the embedded systems out of this STM32 also. So you can use this mental life as these opportunities. So this is about how you are using your this opportunity, how you will make use of it. So you can also you can ask me to you can also prefer me to do and take some new topics like some topics some core concepts you like to be learned, right? You would be want to learn those concepts. So you can say it in my Saturday class to me directly, so I can prepare on those topics, and I will be giving a presentation in this internship. So it will be very much exclusive for the internship students only. Okay, so those even out of the topic not based on STM, if you can ask if you want other topic more than out of this team is, you can also ask me that. So you can prefer me that. So I will take this. I will get into the topic and implement those things, and I will be giving you a recorder session for you, and also I will give a code on developing those things and it for while implementing in a real time. So these are the benefits you can get by this internship. So this is about how you are using this opportunity. Okay. So next is after registering, you will get an internship confirmation letter. So after registering, you will get a confirmation letter, and two, you are going to get a 2 e-certificates. What is this benefit? So you can use this certificates in the resumes. So what is the benefits? Is we are learning STM32 based on Amcodex M4, which is a industrial based controller in a register level, right? We are not using a advanced library, all libraries or some things which will be very much easy like Arduino programming. So we are getting into a register level. So it is in a from zero to ground. We are starting from ground to advanced, right? So this is a basic step. So we have to know about registers to develop the all GPU like drivers. So we are learning STM32 in register level. So this certificate will be very much useful for you. So what are the two certificates we are going to give? We are going to give two certificates. One is for participation and another one is for course completion on this STM32 register level. Okay. So it will be very much useful to you. So the internship fees is 1,200. So don't be afraid. So you don't have to pay this full amount. You can use this ESMC one coupon code so that you can get this 509 discount. And the discount fees is 691 only. Okay. So you can get the internship at 691 only. So this is the registration link, guys. This registration link will be available in the chat box. You can see this, and or you can see this description box. In the description box, this registration link will be available. So join as an internship user and use this internship as a upskilling opportunity for yourself. Okay. So we will get into the concept. We are going to see this. So the Pantech e-learning is offering a 100% placement for your students who was trying to get into the embedded engineering domain or Python domain, Java's data science domain, artificial engineers, and electric vehicle engineering. So these are the domains we are focusing on. The Pantech e-learning is focusing on these domains and providing a 100% placement for these domain-based industries and companies. So guys, you can enroll for this. This link and link will be provided in the description box and as well as chat box. Or you can also use this QR to scan and enroll. So you can join our team. Want to make a career as an whatever domain you needed. So what is the thing we are going to do here is we are analyzing the industries around us. So we are seeing what are the technologies they are asking from the students. What is the technology they have the industry required? So what is the technology that the industry needed? So we are analyzing those things, and as per the industrial requirements, we are training the students, and we are teaching them how to attend the interview and all the things, and we are giving them a 100% placement on based on the domain core industry. So if you take embedded, you will take a scenario of embedded engineer. So you will get a placed in the embedded domain. So the training is going to be based on the what is the as per the industry's requirements. So what are the technologies they are asking from the students? So those technologies going to be going to be get teacher going to train you for the this course for up to 3 to 6 months, and we are going to give you offer you we are going to make you placed in this your dream companies. Okay. So guys, don't miss this opportunity. So you can enroll this. So enroll as soon as to get this. Lots of offers are going on. So you can enroll who's getting first will get the best offer. So register this and get a best offer and get placed in your dream company. Okay. Okay.